Question 9, A part. Obtain basic logic gates from neural networks. Summarize them in table with number of neurons, activation function, and backpropagation in neural networks, if any. Starting with AND gate. Neuron required is one neuron, single perceptron. Activation function for AND is step or sigmoid. For example, if W1 equal to 1, W2 equal to 1, B will be minus 1.5. Back propagation needed. No back propagation needed for AND gate. Output 1 only when both inputs are 1. OR gate. Neuron required is one neuron. Activation function step or sigmoid. W1 equal to 1, W2 equal to 1, then B equal to minus 0.1. Propagation needed. No propagation needed for OR gate. Output 1 when only any input is 1. NOT gate. Neuron required is one neuron. Activation function is step and sigmoid or sigmoid. If W equal to minus 1, B equal to 0.5. Back propagation is not needed. Single input inverts the value. NAND. Neuron required is one neuron. Activation function is step or sigmoid. Example weights and bias. W1 equal to minus 1, W2 equal to minus 1, B equal to 1.5. Back propagation is not needed for NAND. Universal gate. Perform NOT AND. Combination of NOT and AND gate. XOR. Multiple layers of neural networks is required. 2 neuron in hidden layer plus 1 output neuron. The activation function is sigmoid or ReLU. Example of weights and bias for XOR is combine X1 or X2 and X1 NAND X2 then and then. Back propagation is needed in XOR gate, not linearly separable. Requires 2 layer of network MLP. Question 9b part. Compare CNNs, RNNs, GANs and transfer learning in terms of architecture and application. CNN architecture is convolutional plus pooling layer, special hierarchy. The strength for CNN is excellent for special feature extraction. Application for CNN is image classification, detection, segmentation. RNN architecture is sequential structure with recurrent connection. LSTM or GRU. Strength is captures time dependencies. Application is NLP, speech time series. GAN, two computing networks, generator plus discriminator. Strength is generates realistic synthetic data. Application for GAN is image generation, deepfakes, super resolution. Transfer learning architecture reusing pre-trained model layers, fine-tuning. Strength for transfer learning is work with small data and fast training. Applications are medical imaging, NLP, small dataset, domain adaptation. The exam paper is finished now. Thank you.